Dear students, lecture number 17, same chapter. Now I start the galvanic cell, Voltaic cell or Dennell cell. So in this cell, the chemical energy derived into electrical energy. It means that chemical energy converts into electrical energy. In inverse of the previous cell, as we explained in detail. So these redox reactions are spontaneous. Redox reactions are spontaneous. No need to pass electricity. We will not pass electricity here. Just we buy the cell from the market. I just put in the wall clock or in the wristwatch and in the toys also. There are chemical inside. So when the electrodes are connected with each other in the device, so when the circuit is going to be complete, the cell works, oxidation reduction taking place, and the electricity is produced. That electricity is going to be derived some appliances here. So these are spontaneous redox reactions taking place. So in the galvanic cell, Alessandro Volta, Voltaic cell is the name for this one. So a special application, the first very special application for Voltaic cell, the Dennell, he constructed his own galvanic cell, is called Dennell cell, same working, same principles, same uses. There is no difference, just name is different because he used zinc and copper. He constructed his own cell that is made up of zinc and copper. That's why his name is given to Dennell. It's written in your book also. The cell which involves spontaneous redox reactions and electricity is produced in this case. Electricity is produced in this case. So the Voltaic is given the cell because Alessandro Volta, I told you, discovered this cell. Alessandro Volta discovered this cell, that's why name is given here. The English chemist Friedrich Dennell. The English chemist Friedrich Dennell, he used this cell practically and used a zinc and copper couple. Zinc copper couple to explain the oxidation reduction reaction without passing electricity. That is why this is called a Dennell cell. Now the whole procedure is given and also diagram is given here. I am going to explain how this cell works. How this cell works. This is a container. One container. And on the other side there is the same other container. You have this one. You have two separate containers. In this container, you have to put 1 molar solution of zinc sulfate. 1 molar solution. You done the solution chapter, how we prepare the molar solution, molarity. So you have to put 1 molar solution of zinc sulfate in this container. There is 1 molar solution of zinc sulfate in this container, and in this container 1 molar solution of copper sulfate solution. So there is a 1 molar solution of zinc sulfate here, and in this container there is a 1 molar solution of copper sulfate. Galvanic cell we are talking about, spontaneous one. No use of electricity. Electricity is produced in this case. Chemical change in that place. Chemicals are going to be changed. They produce electricity. So, dear students, because now there is no current conduction of electricity. Just I put zinc sulfate in water and copper sulfate in water. Ionization taking place. Nothing changed. No change takes place there. So there is the one device we have to use. This device is called salt bridge. Salt bridge. This salt bridge contains potassium ions, chloride ions in gelatin. This is a glass, and you have to close these two ends by using cotton. Close these two ends because of which solution is going to be flow. There should be no interact between these two solutions. They should not intermix these two solutions without mixing. So this glass salt bridge contains potassium and chloride in gelatin. Potassium ions and chloride ions are going to be here, and they are going to be flow here like this one. So I will explain what is the purpose of salt bridge. Let me finish this construction. Now electrodes. This is the anode. And in the previous lecture, number 16, I told you there are two kinds of electrodes, anode and cathode. Anode has oxidation, and always oxidation, and cathode always reduction. So this is the electrode, cathode. Now the very important thing is here, you use zinc sulfate. You use 1 molar solution of zinc sulfate here. You have to dip the same metal. Means you use zinc sulfate, so this anode must be made up of zinc metal. Zinc metal. So this is the anode. Zinc is dipped in the zinc sulfate. Zinc metal is dipped in zinc ions. And copper, made up of copper. Because copper ions are there. Same. copper ions are there, I put copper as a cathode. And zinc ions are there and I use a zinc metal. So, dear students, the very important thing, always I am giving you the references that you will learn in the higher classes. You can ask the question that why the anode is used as zinc and why the copper is used as a cathode. Why not I use the zinc? This side is no matter. You can use copper here, you can use zinc here, it's no matter. But the matter is zinc acts as an anode and copper acts as a cathode. So why not the zinc cathode and why not the copper anode? According to electrochemical series, reactivity of metals. In simple, I am explaining you. Reactivity of metals according to electrochemical series, zinc is more reactive than copper. We have to see. The metal which is more reactive should be acts as an anode. There should be oxidation. And the metal which is less reactive according to electrochemical series, they are down. In reduction potential, there is a series, there is a table given according to the research, according to the scientists. These are electrolytic cells. So zinc is more reactive than copper. That's why zinc is should be anode and copper should be cathode only at this level. This is only here. Now I put the anode here copper, zinc, and I put here cathode copper here. Now what happened? I don't use battery. Spontaneous cell. This is spontaneous. So how I know the chemical reaction taking place? And these electrodes are not connected. Now these electrodes are not connected. The circuit is not complete. So what happened? I have to use you can use bulb, or you can use the voltmeter. Voltmeter. So when I connect the voltmeter with the anode and cathode, and there is a one point already I explained in the previous lecture, always electron flows from anode to cathode. The flowing of electrons must be from anode to cathode. So when the salt bridge is connected with these two cells, 1 molar solution of zinc sulfate and 1 molar solution of copper sulfate, and you put this salt bridge to connect these solutions together. And how I measure electricity, you can put bulb here. If bulb glows, it means that cell works. And you can put voltmeter, this is a 0 here. So this needle is going to move. The current is going to be shown by the voltmeter. How much voltage is this? This is only information for you, not given here. So this cell, this Danner cell, zinc copper couple, will give students. I will explain this. 1.1 volt. 1.1 volt will be produced by this cell. So this is the complete cell. And students, in a very earlier, very important section we completed before my lectures, oxidation and reduction. If you are discussing electrolytic cell or galvanic cell or Danner cell, so there should be oxidation reduction. So oxidation and reduction must be happening here. We have to write the chemical equation where the oxidation and the reduction is very clear written. Zinc is anode, must be oxidation. Copper is cathode, must be reduction. So there will be oxidation and reduction. Copper acts as a cathode and zinc acts as anode. Electrons flow from anode to cathode. These are the flowing of electrons. Students must be written like this. Flowing of electrons from anode to cathode. Use of salt bridge. the important use of salt bridge is to connect these solutions together without intermixing with each other. They should not mix with each other. Without intermixing with each other, they are going to be connected by using salt bridge containing electrolyte. This electrolyte, potassium ions, chloride ions are going to form in the form of gelatin. So the potassium ions and chloride ions, they pass electric current. And you know this negative ions because why direction is there? Because anode. And why is potassium ions direction here? Because it's a cathode. So this bridge is used to connect these solutions together without intermixing. And other use of the salt bridge is to maintain the neutrality of the solution, electrons. Maintain neutrality of the salt. So if I don't write the salt bridge, how they connect? No connection. They should be connected with each other. Now please, you have to draw this very well. In your book there is drawing in here. See very well. There is 1 molar solution of copper zinc sulfate, 1 molar solution of the copper sulfate, and this is a salt bridge containing potassium. There potassium sulfate can be used there. Potassium chloride, electrolyte. So potassium ions and chloride ions are going to be formed. These negative ions are going to move anode, and potassium ions are going to be moved towards cathode here, and the formation of copper ion in the solution and formation of zinc ions in the solution here. So then how I write the chemical equation? Now understand this diagram, you have to draw yourself. I am now going to write the chemical reactions. I have to go omit this one. See very well. And 1.1 volt is going to be formed from this cell, flowing of electron from anode to cathode. I explained the reason why zinc is anode and why copper is cathode, because according to electrochemical series, zinc is more reactive than copper. It's top, copper's down. Electrode potential. See very well this diagram, then I omit and then I write the chemical reactions here. Okay. Now, dear students, the total voltage of the cell is 1.1 volt. At anode, oxidation. Oxidation takes place at anode, and this is a loss of electron, and I told you zinc metal is going to be oxidized. Chemical reactions are given in your book also. Loss of 2 electrons. It means that in a solution, zinc metal slowly and gradually is going to be dissolved to make sodium zinc ions. Slowly and gradually during the working of the cell, zinc is going to be dissolved and formation of zinc ions, oxidation taking place. So total voltage 1.1 volt. I will write the how much this one. This is the anode. Right? Cathode. There is reduction. So copper ions changes into copper metal by the gaining of 2 electrons. Now these are the reactions. At anode, zinc is going to be dissolved to make zinc ions. Slowly, gradually, after passage of time, and copper ions which are present in a solution, 1 molar solution of copper ion is there, copper ions are there. they change into copper metal. So at copper electrode, more copper is going to be collected. It means that copper ions slowly and gradually going to decrease. The concentration of copper ions will decrease. And zinc metal dissolve to make zinc ions, because in all the redox reaction must be oxidation reduction. Must be oxidation and reduction. So zinc metal change into zinc ions and copper ions change into copper metal. There is a reduction and there is oxidation. And I told you the voltmeter will show 1.1 volt. Every half cell has its own capacity to give the voltage. So I think for the zinc anode cell is 0.76 volts, and for this anode cell I think 0.34 volts. So if you add these 6 and 4, 10, 0, yes. So 0.76 will give the zinc at anode and 0.34 volt will give the copper, and total voltage if I add that will be 1.1 volt for this one. So this is not your syllabus, just I write this one. And this cell, E for electrode potential. In the higher classes you will learn about the EMF, electromotive force, EMF. So electrode potential, this is not for standard electrode potential. Standard electrode potential for half cell oxidation is 0.76 volts. Standard electrode potential for the half cell reduction is a 0.34 volts. Total I add 1.1. I'm not going to detail. Standard. Why we call standard? Because it works at standard conditions. What are standard conditions? You have to use 1 molar solution. If you have a liquid, must use 1 molar solution. 25 degrees Celsius. 1 atmosphere pressure. These are standard conditions. That's why we call standard electrode. Standard electrode potential. In the case of solutions, 1 molar solution you have to use. Pressure maintained for gases, 1 atmosphere pressure, and temperature we use 25 degrees Celsius. So this is called SPP. Standard conditions for this one. So this is Daniel cell students. So page number 170 and 171, these chemical reactions are given for you. So we have many examples for this self-assessment 7.4. So dear students, I'm going to finish the lecture number 17. So inshallah, in the lecture number 18, we have other many examples, and I have to explain the electrolytic cell in the industry how I use. So thank you very much. I stop here.